Hi, it's Jan Beta, and I'm back here with my Amiga 2000 because, as many of you rightly have pointed out in the last video that I did on this machine, which was about the replacement of the fan and the power supply, I have recapped the main board in this, but usually that's not even necessary in these machines because the capacitors are not under a lot of stress and are usually still pretty good. I still did it because electrolytic caps age, and yeah, I wanted to be sure that this has good caps in it, so I replaced all of them on the mainboard because I had all of them in stock. The thing you should really replace the caps in is the power supply that I replaced the fan in. I didn't replace the caps in the last video because some of the values are pretty hard to get, especially the ones that have 680 microfarads and 200 volts that are the mains filter caps, basically the first big caps that are in there. Those are pretty rare actually and get very expensive. I found some at Conrad, which is like a German electronics reseller. They usually have a lot of stuff in stock but can be quite expensive. So I found the last two capacitors of that kind there and I ordered them, and then the package got lost. They actually had some other stuff in there, and they had a very nice customer service, and somebody contacted me via email, and they are packing another package and refunding me and stuff like that. So that's not a big deal. But those were the last two capacitors, and they are somewhere now, but not at my place. So yeah, they are. I could go on eBay and order them from some foreign country, but it will take a while. And as these mains capacitors, usually the larger value capacitors usually are still good in the power supplies and hold up very well against time, they are not necessarily the most important ones to replace in these PSUs. So whenever I get some of those, I'm going to replace them too. But for now, I'm just going to focus on the other capacitors, which are far more important and far more likely to leak and to degrade with time because they are put under high stress and high switching frequencies, because obviously this is a switching power supply. So yeah, let's get out the power supply and get to work. If you're a good observer, you probably noticed that I have a hard disk in here, which is like a modern niche 120 gigabyte IDE drive. I also have like a memory expansion, and I have like this Buddha IDE card, which is an IDE interface for the Amiga machines, which is pretty handy. I'm still waiting on some parts, but as soon as I have them, I am going to make a video about all this stuff. For now, just ignore it completely as if it wasn't there. We are focusing on the power supply, that is this fella here. So you take out this whole section, and the power supply is secured with these two screws here. Then the power supply itself has three screws on each side that you have to loosen. You saw that in my fan replacement video probably, if you were following that. So now this seems to be secured in with three screws, 1, 2, 3, and there's no screw, at least as far as I can see, below the fan, which is pretty handy because the original fan was riveted in, so you wouldn't be able to reach the screw without dismantling it fully before. So of course we have to take this out here to be able to work on it. Yeah, that's it actually. So, and we want to be careful with the capacitors. We want to discharge them. Even though I believe there is like a discharge resistor in here that discharges the large caps, so they don't store any current anymore. So we are going to be extra careful, and I want to show you how this is done. You could just go in there and short them out, like both plus and minus, with a screwdriver or something made of metal, which is insulated, so you won't get shocked. It is a bit harsh on the capacitors, so I made a little device that has a resistor in it that discharges them slowly. I think it's like a 100 ohm cement resistor that I put in there. About that, or a smaller one will do as well. Just something that discharges the capacitors. You short them out through this resistor basically, so the resistor takes the load away from the capacitors and it won't discharge with a bang. Usually if you short those you get a little flash and a little bang. That's because they discharge all their energy at once, because they are basically dead short then. Which is of course not very nice on the capacitor. So I made the device that I'm going to show you in a second. So here it is. It's basically a cable with one side is a banana plug that I insulated with some heat shrink tubing. The other side is like a crocodile clamp that I also insulated a bit more. And this is a resistor that the cable goes through the resistor, obviously. So the voltage goes through the resistor. So we are going to ground this. There's the ground. I think the whole case is ground. Yeah, it's connected through to ground. So we can just be safe and just touch the both ends of the capacitors here. And then wait for a bit and rub it a bit so you make good contact. So you can do that with the other larger caps as well, if you so desire. Also, the 200 volts caps basically can store 200 volts, so these are the ones that are dangerous, potentially dangerous if you touch them. So then after that I usually go in with the multimeter set to volts DC and double check if they don't store any voltage anymore. Yeah, and as you can see, can you see it? Yes, you can. There's nothing in there. Absolutely no voltage left. So these are now discharged and it's safe to work on this and touch them and stuff. So yeah, let's go in and recap this power supply board. And I think I won't take it out of the casing because I only need to reach the underside. And yeah, I don't have to dismantle the whole thing and take the cables off from the mains plug here and stuff. So I think I can work like this. And as for the capacitors, I think I have all of these here on this side. I can replace all of those and the smaller ones that are beneath there. There's a whole lot of small ones, like 1 microfarad stuff and things like that. These big ones were the ones I was talking about earlier, 200 volts, 680 microfarad. I'm going to put a list of capacitors that is in this Phiphong PSM-2000 model. There are various models of Amiga 2000 power supplies. This is the one I have, so I can only talk about this one. Yeah, I'm just going to put a list of capacitors down below, and there's a lot of glue on there and stuff. We're going to see how well these come out. Yeah. As for the type of capacitors used to replace the old ones, I got some low ESR ones, which are 4700 microfarad 10 volts ones. They have the exact diameter of the old ones, or the old ones are a lot higher. But these are basically much smaller. You usually would use all low ESR type capacitors in a switching power supply nowadays, as these are from the late 80s. You can go with low impedance capacitors as long as they are good. They will have lower ESR than anything that was available in the 80s, especially these Nikon, I think, caps. These are Rubicon, the big ones. They are probably pretty good still. I have some low ESR ones, bought these, and the rest of them are low impedance or other multi-purpose caps that I'm using, and I'm probably going to be fine with that. Because the ESR in the 80s, they didn't quite reach the low values they reach today with modern caps. So we're going to be fine anyway. So that said, let's get right into it. I usually do one capacitor at a time and take note of the polarities so I don't get it confused with anything. These have a lot of this glue on them. You can usually just, this is just silicone stuff, it's like rubbery feeling, it's like a bit soft, so you can usually just wiggle it out, even though it's glued. They are glued together to prevent them from vibrating, because this obviously has a fan, and the fan causes vibration, so you don't want your capacitors to vibrate all the time, which can cause damage and make them age, and cause weird behavior of all kinds, basically, and break the solder joints and stuff like that. So you don't want that. So you just dip them a bit in some silicone glue. So yeah, maybe we are going to do that after we recapped it, but I don't think it's really necessary, because the new fan is pretty much, it has rubbery standoffs, so it is pretty much very vibration less compared to the old one. So fired up my desoldering station that I made a video about years ago. It's ZD915. I have the second handpiece because the first one started to clock very frequently, so I couldn't really use it anymore for any longer period of time. So I went and bought a replacement one, and this one basically works like new. So there we go, all recapped except for the big ones. As I said, these are the capacitors you need. I'm going to list them below in the description for this video, so you don't have to do what I did and go in there and check every capacitor value. So yeah, let's reassemble it and see if it still works. Okay, I'm always a bit nervous with these kind of repairs, refurbs, recap things, because it is a high voltage device, a mains voltage device, and there might be explosions if you turn this on. Actually, if you put in a capacitor the wrong way round, in the wrong polarity, it is going to explode. So I'm always a bit, I'm always a bit nervous about these things. So, yeah, I refrained from putting any glue between the capacitors because they are sitting pretty tightly together anyway, and I don't think it is really necessary. So yeah. Without further ado, let's just turn this thing on and see what happens. Whoa, okay. And it actually seems to still boot. This is actually from the hard disk that I inserted there. Let's just leave this running for some time. I'm going to trust it if it ran for a while, so but it's pretty nice that it didn't explode right away. So I think I did something right there. So it works. It works. It continues to work, and it still works, and it seems to have gone well. And I actually think the picture quality, the video quality, has improved a bit. So it is a crisper picture now, even though it's going through my crappy Flylink upscaler thingy and stuff like that. But I still think that the picture quality actually improved. So there were some capacitors that weren't quite as good in the power supply. We should measure them, I think. Yeah, we had this running for some time now, and it didn't explode, and it doesn't smoke, and it works. So that's good. That's actually very, very good. So yeah, let's measure the capacitors there, and see if there's any broken ones or leaky ones in there. Actually, it seems like it's looking better. The cleaner the power supply is, the better this is going to work, and the less distortion you will get in the picture, and noise in the picture, and in the sound actually. So yeah, this worked out pretty nicely, I guess. Let's measure some capacitors. So I'm using my Atlas ESR 70 Plus, which is a pretty fancy one. But yeah, usually you don't need a fancy thing like this to measure ESR. You can do it with one of those cheap component testers. But as I have this has a good ESR. My guess would be the big ones are still very good. Yeah, this is very good actually. This has like 5,500 capacity, much more than it's rated for. So this has a very good ESR too. And a higher capacitor than it's rated for. I guess the big ones are alright. The big ones usually die much later. This is also good. Good ESR. Probably good capacitance. So the big ones wouldn't have been necessary to replace. Necessarily, I guess. Still good ESR. Yep, pretty good. So the big ones are basically all the same. This one is a bit worse, but 0.1 ohm or something. Okay, so that's pretty good. Let's measure the smaller ones. These are going to be more interesting, I guess. Okay, this one's good. 220 rated, 240 measured. This one's 100. It's also still good. Now we're getting to the more interesting stuff. Guess one of the small ones must be gone. That's like 48. This is a 47 one. Wow, these are getting physically difficult. Okay, so this is not quite as good. This is supposedly 1 microfarad. It's a bit under the capacitance. It has a bit of a high ESR. It would still be in spec, I guess. One of those. Yeah, same here. So the lower values usually age faster, because they have less electrolyte, basically. That's like the physical reason. Okay, that's good. Okay, that's not quite as good, but still okay. Okay, that's also pretty good, still okay. So they were all okay. The power supply was working, but as you saw, the ESR for some of the lower capacitors was a bit high. So we are probably fine with the new capacitors in there that all have a lower ESR, I guess. So yeah, so much for now. Hope you enjoyed this. Hope this was informative. As I said, the capacitor list is going to be in the description if you want to do the same. Be careful to not zap yourself or zap any components. If you enjoyed this, check out my other videos and maybe subscribe to my channel. If you enjoyed this enough to be willing to support me, check out my Patreon page. There's always going to be some behind the scenes stuff and early bird videos and stuff like that. So yeah, so much for now. Thanks for watching. I'm Jan Beta. See you next time. Bye. Without much ado, let's just try and power this on. See what happens.